checking out the sun in 304 angstroms. We got some active regions north of the equator. Some plasma filaments. High electron flux. No sunspots. And generally weak solar activity. Checking out the view in 171 angstroms. See some interesting filament activity, which we're going to zoom in on in a second. But first we want to look at these active regions. None of them are sunspots. And let's take a look at this filament up here. Go northwest, young filament. Go northwest. Not to be confused with Kanye Northwest. Or Kanye's, yeah. Not to be confused with Kanye. Looking at the 335 angstrom view with the magnetic lines. And last but not least, let's look at the actual magnetometer. You can see the fields associated with these active regions. The Earth-facing quiet effect. In effect again. Let's just take a quick look at solar ham. Solarham.net. We'll leave links below. No umbra associated with any of those active regions. Let's look at the LASCO C2 while we're here. Let that play through. You can see a comet flies in, gets consumed by the sun. At the same time, a CME comes out of the eastern limb. Right about there. And let's look at some other data here at spaceweathernews.com. Goes X-ray flux, still flatlined. No surprise there. No phi angle signal. Solar wind density is around 4. That's protons per cubic centimeter, by the way. And the solar wind speed has dropped, has dropped down to about around 400. Some interesting perturbations in the magnetometer there. Nothing too extreme. Similar to yesterday, we're seeing lower highs and higher lows. KP index is back to 1. Cosmic ray alert is in effect, although 1's better than 0. Electron flux levels are still high, but remaining below 10 to the 5th, where we get into electron storm territory. No charging hazards, really. The F2 layer looks much more charged than it was yesterday morning. You can see we've got all the way up to 11 megahertz in the charged portion, and the discharged portion by South America is not looking as discharged. So that's a new development compared to yesterday. There's your aurora forecasts. Nothing too exciting going on there. Now let's revisit let's look at the earthquakes. We'll look at the last about 10 hours. So Nicaragua got a 4.5. Alakahardi Yi Kira, I can't pronounce that. Alakahardi Yi Kira Wa Munhan in Afghanistan got a 4.9. Some Alaskan quakes, a Chile. There's one on the West Chile Rise, just off the coast of southern South America. And the most recent, the Reconnaissance Ridge. Right on the plate boundary there, near the North American plate. Slightly to the southwest of Iceland. Now let's revisit an article that we covered a few weeks ago from phys.org. One of the many reasons astronomy textbooks are about to be rewritten and have to be rewritten so that they're correct. Anyway, we'll leave links to this article below. This is an ALMA image of the supermassive black hole, or as we call it, radio source, at the center of the Circinus galaxy. You're looking at carbon monoxide gas and atomic carbon, shown in orange and cyan. Well, what's the relevance? Well, we'll let you read the article yourself, but black holes are not simple donut shapes. Instead, they're shaped like fountains. Let's look at the data, and there you have it. So, you've got this disk. This is your rotational disk. This is where your ionized particles get charged up. They get drawn in. As they get closer and closer, they start to rotate faster and faster. Some of them are lost in the black hole's confinement dome. And you can see the telltale signs of primer fields right here. Here's your spiraling Z-pinch effect. And we wish this image was zoomed out a bit, because it's not showing what really happens. But what really happens here is these jets are coming out and then they're coming back in, just like that. There's no tunnel to another dimension. It's just condensed matter and a massive radio source created by these magnetic fields. Read the article, super interesting. And we've got another article here, also about magnetic fields. Tangled magnetic fields power cosmic particle accelerators. As we've been saying for ages. Anyway, this is an artist's rendition of a galaxy. Here's your same kind of jets coming out of the poles. And what they did is they created a simulation, a computer simulation, that is, of what's happening inside those jets of highly ionized plasma. And here's a little animation that they put together from their measurements. So you see the electric current is emanating from the magnetic field, and then there's an axial current also. Interesting article on phys.org. Please read if you're interested in the way that magnetic fields control your universe. Next, shout out to Virgin Galactic. Virgin Galactic creating space tourism by the end of next year. So by Christmas of 2019, you should be able to purchase a Christmas present to fly somebody into space. Check it out. They pulled off their first test yesterday, reaching an altitude of 51 miles or 200,000 feet. 271,268 feet. Fantastic. Nice job. And We appreciate the idea of putting private business into space due to the inefficiencies of government. Now let's look at a nonsensical article that doesn't understand what happens during a solar minimum and during global cooling. Well, it turns out global water supplies are shrinking. We'll leave links to this article too. And this is absolutely true. And this is absolutely an effect of solar minimum. When the planet gets really cold, more ice ends up at the poles. Now, in reading through this article, we were actually surprised that they didn't throw any global warming stuff in until the very end. But once you get about 2/3 or 3/4 of the way through the article, yep, they're going to throw global warming in there. Turns out that when the planet cools, it actually gets drier. And it makes perfect sense, because if you evaporate more water and then you get it cold, it's going to show up at the ice caps. Antarctica, the Arctic ice, Greenland, all areas where ice is growing. So, yeah. Anyway, it's long been known that there are certain places, especially like Australia, parts of Africa, parts of Southeast Asia, where there are extreme droughts, as well as, of course, the west coast of the U.S., the whole Southwest, pretty much in a massive drought. Global cooling. The water is going to the poles. Now, talk about the Parker Solar Probe again. Super, super excited about the Parker Solar Probe, because we're going to all kinds of things about the sun, which are going to prove what the sun's made out of. It's going to prove why the corona accelerates. And we actually know why the corona accelerates in heat. It's because of things like electron affinity and chemical reactions. But anyway, the Parker Solar Probe, which is the fastest object ever made by man, as far as we know, has already done its first approach. It reached speeds of over 270,000 miles per hour. Let's hope they disprove special relativity and time dilation too. But that said, one of the greatest mysteries about the solar wind is how come it gets hotter when you get farther away. Yeah, well, there's a reason for it. And we're not going to get into the weeds too much talking about it. But the observations of the sun do not include anything suggesting that there's a nuclear dynamo in the center. It's not the way it works. Parker Solar Probe is going to prove that that's not the way it works. And on a related note, I'd like to recommend you a video that we recommended to one of our commenters last night. We watched it ourselves because, well, because it's always nice to have a little refresher in the actual observations of astronomy. And so let's watch in the next month or two as all this stuff becomes proven. So, we're going to leave a link to this video also. What's the sun made of? Evidence from the solar spectrum. Hint, it's metallic hydrogen. Let's play you a little clip.
The answer is simple. The only requirement is that the hydrogen nuclei must be close enough to each other to allow for the proper quantum conditions to enable the formation of the conduction bands. It is the presence of the conduction bands, or the ability to at least partially delocalize the electrons, which lock the hydrogen nuclei into a lattice, requiring nothing further.
So there you have it. Learn about the sun, study it, stare at it. Thanks for watching the videos. Please like and subscribe if you enjoy the content. We'll be doing it all again tomorrow. Help us get to 1,000 subscribers. Leave us a comment letting us know what we should do for the 1,000 subscriber special when we get there. And remember, when you're concerned about the true structure of the sun, don't drink. And if you drink, concern yourself about the true structure of the sun, because it affects how we view the entire universe, such as the mass, the age, the behavior of stars, and everything else in cosmology.